What scares you more about space, the thought of a black hole swallowing entire stars like they never existed, or the idea of drifting endlessly in a frozen ocean of silence? Most people fear the violence of space, the explosions, the collapsing stars, the chaos. But what if the most terrifying thing out there isn't destruction, but nothingness? A place so empty, so vast, that it challenges our very understanding of reality itself. These are the cosmic voids. At first glance, they might look like just blank spaces between galaxies, cosmic gaps with nothing inside. But in truth, they are among the strangest and most mysterious structures in the universe. They stretch for hundreds of millions of light years, containing almost no matter at all. And yet, despite their emptiness, they secretly shape everything around them. Some scientists even believe that within these dark regions lies the key to understanding the deepest mysteries of the cosmos. But before we get to the most famous of all voids, the one astronomers call the Great Nothing, we need to understand how the universe itself is woven together. If you zoom out far enough from Earth, far beyond galaxies and clusters, the universe begins to reveal a strange pattern. Galaxies don't scatter randomly like grains of sand. Instead, they connect into a massive network, stretching across the cosmos in threads and knots. Scientists call this vast design the cosmic web. Picture it like a spider web spanning the universe. The threads are clusters of galaxies bound together by gravity, while the spaces in between, the vast, dark gaps, are the voids. By sheer volume, most of the universe isn't galaxies, stars, or planets. It's empty. Nothingness dominates everything. But here's the twist. These voids aren't just random patches of emptiness. They subtly guide the movement of matter, shaping where galaxies form and how the universe evolves. In a strange way, nothingness is just as powerful as something. And if the cosmic web is the skeleton of the universe, then the voids are its hollow lungs, expanding, stretching, and defining the spaces where life cannot exist. It's hard to imagine just how empty these voids are. To give you a sense of scale, think about driving across the United States. Normally, you'd pass through towns or cities every few hours, but in a supervoid, you could keep driving for hundreds of years without ever seeing a single light. That's how barren they are. One of the most puzzling examples is the Eridanus Supervoid, a region stretching nearly 1 billion light years across. That's so big it could swallow multiple galaxy clusters whole. Astronomers think it may be connected to the so-called cold spot in the cosmic microwave background, a mysterious patch of the early universe that appears cooler than its surroundings. The emptiness of the Eridanus void might be the reason light traveling through it loses energy, creating this chilling cold imprint in the cosmic afterglow. Another is the so-called giant void, stretching over 1.3 billion light years. Just saying 1.3 billion light years doesn't do it justice. Imagine a space so vast that, even at the speed of light, it would take longer than Earth's entire history just to cross from one side to the other. And yet, inside that entire region, the number of galaxies is a tiny fraction of what you'd expect. The existence of these supervoids has left scientists scratching their heads. How could something this enormous have formed in the limited time the universe has existed? Could they be natural products of galaxy clustering? Or do they suggest something deeper that maybe our models of cosmic evolution are missing a crucial piece? One thing we know is that voids aren't frozen in time, they're growing. As the universe expands, galaxies are pulled farther apart and voids stretch wider and wider, deepening their emptiness. And this growth may hold the key to one of the biggest mysteries in science: dark energy. Dark energy is the invisible force driving the accelerated expansion of the universe. We can't see it directly, but its fingerprints are everywhere, and supervoids may be the best places to study it. In these regions, the tug-of-war between matter and emptiness is written across billions of light years. As galaxies drift apart, the voids act like magnifying glasses, showing us dark energy's influence in real time. But here's the puzzle. The way light passes through these voids doesn't always match what we expect. Some scientists suspect that supervoids may actually distort or slow down light, leading to conflicting measurements of the universe's expansion rate. If that's true, then these empty regions might be hiding answers to the most controversial question in cosmology: why our estimates of the universe's growth don't add up. And if that mystery wasn't enough, the voids also reveal something even stranger: clues about the invisible skeleton holding the universe together, dark matter. Dark matter makes up most of the mass in the universe, but we can't see it, touch it, or detect it directly. Its existence is revealed only by its gravity, the way it pulls on galaxies, bends light, and sculpts the cosmic web. Voids, in a sense, are the shadows of dark matter. They mark the regions where dark matter didn't clump together, where it's weakest. By studying the emptiness, astronomers can reverse engineer the role dark matter played in shaping the universe. Think of it like footprints in the sand. You may not see the person who left them, but the absence, the hollow in the ground, tells you they were there. In the same way, the boundaries of cosmic voids show us where dark matter once gathered and where it left nothing behind. But the deeper we peer into these voids, the more the universe begins to feel unnatural. Because among all the empty regions, one stands out. A void so immense, so puzzling, that some scientists call it the Great Nothing, and others wonder if it might be something far stranger. When astronomers first discovered the Bootes void in 1981, they weren't prepared for what they found. At first, it just looked like a patch of sky with fewer galaxies than expected. But the deeper they looked, the more shocking it became. This wasn't just a slightly empty region. It was a desert of galaxies, spanning nearly 330 million light-years in diameter. To put that into perspective, a region of space that large should normally contain thousands of galaxies. Yet inside the Bootes void, astronomers could count only around 60 galaxies scattered like tiny campfires in a pitch-black wilderness that should have been bursting with light. This discovery stunned the scientific community. The Bootes void was simply too empty. It didn't fit the models. How could an area that big have stayed barren for over 13 billion years of cosmic history? Why didn't galaxies form there like they did everywhere else? Some scientists nicknamed it the Great Nothing. Others went further, calling it a cosmic anomaly, a mystery that still has no satisfying explanation. The most widely accepted theory is that the Bootes void wasn't born as one giant gap. Instead, it may have formed from several smaller voids, merging together over billions of years. Like bubbles in foam colliding and becoming one larger bubble, the galaxies on the edges may have drifted away, leaving the center frighteningly empty. This could explain the strange tube-like arrangement of galaxies that do exist within the void, as though they were remnants of the walls of smaller voids long ago. But not everyone is convinced. The Bootes void is unusually spherical, far more uniform than we'd expect from random cosmic evolution. And the galaxies inside aren't scattered randomly. They seem oddly aligned, as if shaped by something more deliberate. That has led to more radical possibilities. Some researchers have speculated that voids like Bootes may not be just natural gaps at all. Instead, they could be regions where our universe brushes up against other universes. This idea ties into the concept of the multiverse, a vast collection of parallel realities, each with its own laws of physics. If true, then maybe the Bootes void is a thin spot in the fabric of our cosmos, a kind of buffer zone where matter is stripped away because another universe presses against ours. There's no hard evidence for this, of course, but the sheer strangeness of the void invites speculation. After all, why would the universe leave such an immense region so utterly barren? Could emptiness itself be the clue that we're not alone, not just in terms of alien life, but in terms of entire universes? A more grounded, though still mysterious, idea is that some catastrophic event happened here billions of years ago. Maybe an enormous concentration of dark matter, or even a supermassive black hole passed through this region early in cosmic history, sweeping matter away like a broom. This would leave behind a hollow scar in space-time, a void so thoroughly emptied that galaxies never had the chance to form. If true, the Bootes void isn't just an absence, it's a fossil, a leftover mark of an ancient cosmic disaster we'll never directly witness. Whether the Buttes void formed naturally, through ancient events, or something stranger, one thing is certain. These cosmic deserts aren't just empty spaces. They're laboratories for understanding the deepest mysteries of the universe. They show us how dark matter shaped the cosmos. They reveal how dark energy continues to stretch reality itself. And they hint at possibilities far beyond anything we've proven, from multiverses to civilizations that might have left their mark on the largest scales imaginable. Voids remind us that the universe isn't just full of stars, galaxies, and light. It's also full of silence. And sometimes, the silence is more terrifying than the noise. Black holes may consume stars. Supernovae may tear apart solar systems. But nothing compares to the chilling emptiness of the cosmic voids. They stretch across reality, like silent oceans, too big to comprehend, too empty to ignore. And the Buttes void, the great, nothing stands as a reminder that the scariest thing about the universe isn't what's out there trying to destroy us. It's the possibility that most of the cosmos was never meant for us at all. So the question isn't just what's hiding inside these voids, it's whether the voids themselves are trying to tell us something about dark energy, about other universes, or maybe about our own fragile place in the infinite unknown. Because in the end, the most terrifying secret of space may not be found in the light of the stars, but in the darkness between them.